Welcome students, today is Friday, January 29th, and we are continuing our work with fractions. We're now on lesson number 5, equivalent fractions using the tape diagram. This is our multiplication table that I have in here as a resource for you, just in case you need it to go back and you need refreshers on your math. And the next couple slides, again, are where you are able to put a picture of your work. You have to show a picture of your work to your teacher so that you can get credit for your work, as if you're working in the binder or if you're working in your notebook. Our learning targets for today: I will expand my thinking of fractions by exploring how to model equivalent fractions using the tape diagram, and I will create visual models and written explanations to explain my thinking. Our essential questions: why might it be important to understand equivalence, and why is unit size important in mathematics? We are continuing to build upon those questions in this entire unit. Now back to our vocabulary. We've been working on this vocabulary all week long, and here we have the same words: equivalent, equal parts, fraction, numerator, denominator. Yep, there's a change. We've added one to it: tape diagram. Tape diagrams means using a visual drawing to show equivalent fractions using a long bar. All right, so go ahead and write this down in your notebook, guys. Write this in your notebook, and you'll see as you write, this one shows that 2/5 is equivalent to 6/15. So if you notice, for the whole part, they're the same size. They're just partitioned differently. So the top one's been partitioned into 5 equal parts, and the bottom one has been partitioned into 15 equal parts. But by looking at the shaded areas, you can tell that they're the same. The same amount is shaded in for both. This is an example of a tape diagram. So pause the video as you need to make sure you write this down in your notebook. All right, for our next slide here, guys, we have a different scenario that we're going to work on. And for this one, you can use your whiteboards, or you can use your math journals, or you can use the online color tiles right here by clicking on this one, okay, to help solve it. I'm going to read it first and we can kind of go over it. 2 friends were training for a race. On Tuesday, Marlo ran, and I've got to fill in the actual. Okay, so I've added this to a Jamboard. So you're actually able to use a Jamboard, whiteboard, or your notebook to solve this. And the training dilemma: 2 friends were training for a race. On Tuesday, Marlo ran 4/5 of a mile and Carlos ran 8/10 of a mile. Marlo told Carlos, "I ran farther than you today," but Carlos disagreed. He thought he ran farther. Who is correct? Prove your answer with a visual model. Okay, so we're going to go, and I'll show you the Jamboard. All right, so this is a Jamboard we're going to work on. We're going to go to this, come to this a little bit later, but if we go to the second, this is our training dilemma here. And when we look at it, and we go ahead and do our cubes on it, we got, let's see here, 4/5 for Marlo, 8/10 for Carlos. So who is correct? Prove your answer with a visual model. So who ran further? So let's see. We're gonna go with let's say Marlo, and we're gonna do tape diagrams for these. All right, so we're gonna do tape diagrams. So that means that we're just gonna do a little rectangle here, and we need 5 equal parts. 1, 2, 3, 4. 1, 2, 3, 4, 5 equal parts there. This is for Marlo, and let's see, Carlos. All right, so they both have to be the same, and we're going to say that these are the same lengths, represent a mile. So Carlos, 8/10 of a mile. So let's go. We got to do 10 equal parts here for Carlos. 1, 2, 3, 4, 5, and we'll put this right in the middle. So we need 10. Let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right, so we got Carlos and Marlowe. So let's see here. I'm going to change my color. So Marlowe ran 4/5. So we need 4 out of these 5, 4 out of the 5 shaded in. And for Carlos, we need 8 out of the 10. So 1, 2, 3, 4, 5, 6, 7, 8 out of the 10. Now, if you look, this line right here, they look to be equal. So that means that 4/5 is the same as 8/10. They're equivalent to each other. So they're both correct. So they are both correct because they have equivalent distances there. So I'll just write that both are correct. Okay. All right, so that's your answer for that one, guys. All right, so we finished up the training dilemma, and this is just a discussion about the training dilemma, and I've already gone over that one with you guys. So our next slide, explore equivalent fractions with tape diagram. That's the diagram that we just used. So in our next slide, we're going to continue to explore equivalent fractions with the tape diagram. And we've got a picture of a tape diagram that's right at the top right here. And I want you to take a minute to to look through it, examine it really carefully, and we're going to, just kind of look at some of the questions on here. All right, so looking at the picture again, and looking at some of the questions beneath it. So what does this picture remind you of? You could have said maybe a ruler, possibly. So how do we know that this is 4/12? Well, there are 4 shaded in parts out of 12 total. So if you counted them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 equal parts and there are 4 shaded in. That's how we know that it's 4/12. So how can this fraction be shown in another way? And we'll be exploring more of this. So how can we explore this fraction in another way? That would mean, what is an equivalent fraction to 4/12? What would be an equivalent fraction to 4/12? Okay, and we've done some work on that already. So you could say that 1/3, it can be shown as 1/3. So if you had this divided into just 3 equal parts instead of 12, let's see, if this was 1 part, then we did 4 more, we did a second equal part and a fourth. So if we had 3 equal parts on here, we just had that 1 equal part shaded in the first one, that would be equivalent to 1/3. Okay. So on the next slide, you're going to continue exploring equivalent fractions with tape diagram. Now this is on a Jamboard. So I've got this on a Jamboard, but it's also on page 157. So it's on a Jamboard, but it's also on page 157 in your binder. So you have this is what it looks like on page 157, and on the Jamboard, this is what it looks like. Okay, so I want you to go in and start working on that, and we're gonna go over it in just a few minutes, but I want you to work as many of them as you can right now. Okay, and that's just the same Jamboard as we did with the training dilemma, but it's just the first one. Okay, so go in and work on those, and we will come back and look at our answers in just a few minutes. So this, on our next slide, guys, is our answer key to the one we just worked on. And the first one, directions say to show the fractions 3/8 and 4/5 on the tape diagrams. So you had to actually complete it. So you have 8 equal parts, and 3 of them are shaded in. So that represents 3/8. And on the second one here, you're showing 4/5. So you got 5 equal parts, and you got 4 of them shaded in. And you go down next, write the 2 things you notice about these fractions based on your models. One thing that you could say is that the fifths with the bottom one is showing fifths, it represents larger parts. The eighths up here, it represents smaller parts. And the 4/5 has more shaded in area, so it's bigger than the 3/8 here. And you go down to the second one. So how many 6 does it take to make the same amount show your thinking. Okay. And your answer here should be 2-6. 2-6 for this one. And lastly, you got number 3, construction workers completed. I think we're missing a fraction on this one right here. Okay, so just continuing on, guys. So how many 6 does it take to make the same amount as 1/3? So you're thinking with a tape diagram. So you would say 2/6 is equivalent to 1/3. So 2/6 is equivalent to 1/3. And the third one, construction workers completed 2/8 of the highway at night. How many 4ths did they complete at night? Show your thinking with a tape diagram. So here's a comparison. You got 2/8 on the top and there's 1/4 at the bottom. So how many 4ths did they complete at night? 1/4 is what they completed at night. All right, so our independent practice, guys, is going to be on page 159. Page 159, and this is what 159 looks like. Now this is also going to be in a Jamboard. So you got an option of doing the Jamboard for this, or you can do it in your binder. And if you do it in your binder, make sure to take a picture of your work and insert it into the slides. Lastly, this is a reminder of our independent work. So you're going to complete the Jamboards or on page 159. And also you're going to work on Dreambox.